Today's notes are a continuation of what we've been working on with solving systems of equations by elimination. They are a little bit different than the ones we've done thus far. They are going to require just a little bit more work. So even if you feel like you completely understand what we've done thus far with elimination, you're a master of solving systems by elimination, let's make sure we're taking good notes today, understanding the material so you're ready to move forward. So here we're asked to solve this system by elimination. We're given 4x plus 6y equals negative 22 and 7x minus 4y equals 34. When we solve by elimination, we want to add the two equations together so that one of the variables eliminates. 4x and 7x don't eliminate, 6y and minus 4y don't eliminate. So we do want to multiply an equation by something. If you look at 4 and 7, 4 times what gives us 7? There's not an integer, there's not a whole number. You could use a fraction, I guess, but we don't want to do that to get 7. And if you look at the y's, 6 and 4, if I'm trying to make this 4 into a 6, again, there's not an integer I can multiply it by. Yes, you can multiply it by 1.5, but again, we don't really want to do that. So instead, what we're going to do is we're going to multiply both equations by different things to make the variables the same. So 4 and 7, we're looking for a common multiple. What I could make both of those, you could make them both 28. Or looking at the y's, 6y and 4y, 6 and 4 have a common multiple of 12. I could make those both 12. So 12 smaller than 28, so let's work with the y's here. So I want to make this positive 12y. To make that positive 12y, we need to multiply that equation by 2. 6 times 2 is going to give me 12. I'm multiplying the entire equation by 2. 4x times 2 gives me 8x. Positive 6y times 2 is plus 12y. Negative 22 times 2 is negative 44. If this top one is positive 12y, I want the bottom one to say minus 12y. So I'm looking at this term right here. Right now it's minus 4y. I need to multiply it by something so that this says minus 12y, so that these cancel out. Minus 4 needs to be multiplied times 3, and that's going to give me minus 12. So we need to multiply the entire bottom equation by 3. 7x times 3 minus 4y times 3 is indeed minus 12y, and 34 times 3 gives me 102. And now the problem's just like all the other ones where we can cancel these out, add the equations together, and go from there. So notice sometimes instead of just multiplying one equation, we're going to multiply both equations, and we are allowed to multiply them by different things. So from here, 12y minus 12y, that cancels. I'm adding my equations together. 8x plus 21x gives me 29x. And 102 minus 44 gives me 58. Divide both sides by 29. Gives me x equals 2. Once I have x equals 2, I can go back to any of my original equations. You could go to these if you wanted. I would go back to one of the equations that's given. I'm going to choose the first one, and we're plugging 2 in for our x. So I have 4 times 2 plus 6y equals negative 22. 4 times 2 gives me 8, plus 6y equals negative 22. Subtract 8 from both sides. 6y equals negative 30. Divide both sides by 6, and we get our y value. Y equals negative 5. X equals 2. Y equals negative 5. As always, if I go too fast, pause it. Give everybody a minute to get caught up. Example 2, again, asks us to solve the system of equations by elimination. We are given 2x plus 7y equals 11, and 5x plus 5y equals negative 10. To solve by elimination, we want to add the equations together. I can't yet. Those don't cancel, and these don't cancel. So I want to make it so that when I add the equations together, they will cancel out. 2 and 5, I could make those both 10. 7 and 5, I could make those both 35. I think that 10 is going to be easier, making these both into 10. So if I want this to be 10x, I need to multiply this top equation times 5. Multiplying the top equation by 5 is going to give me 10x plus 35y equals 11 times 5, 55. The bottom equation, I also need to have 10x, but if I multiply this by 2, that's going to give me, I've got 10x on the top, and that's going to give me 10x on the bottom. 10x and 10x make 20x. They don't cancel. I need one of them to be negative 10. So I multiplied the top by 5 to get positive 10. Let's multiply by negative 2 in order to get negative 10 here so that these do indeed cancel out. In order to cancel them, one needs to be positive and one needs to be negative. So I multiplied by negative 2, that gives me negative 10x. 5y times negative 2 is minus 10y. Here I get negative 10 times negative 2. Negative times negative is positive 20. 10x minus 10x, gone, cancels. 35y minus 10y is 25y. 55 plus 20 is 75. Dividing both sides by 25 allows us to solve for y. I get y equals 3. And again, once I get y, x is not too bad. We go back to one of the original equations. I'm going with the top one, and we plug 3 in for our y. So now it would say 2x plus 7 times y equals 11. But instead of y, I'm putting in what y is equal to. I'm putting in 3. 7 times 3 is 21. Subtract 21 from both sides. 11 minus 21. One's positive, one's negative, so we subtract them. 21 minus 11 is 10. The bigger number was the negative one, so negative 10. Dividing both sides by 2 gives me an x value of negative 5. Y equals 3, x equals negative 5. We're going to do one more of these. 10a plus 4b equals negative 28. And negative 7a plus 6b equals negative 42. 10a plus 4b is negative 28. Negative 7a plus 6b equals negative 42. Again, I can't add them together right away. It'd be nice if you could. I would always check that first, though. 10 and 7, I could make them both 70. It's the smallest common multiple between 10 and 7. 4 and 6. 4 and 6, we could make those both 12. I'd much rather go with 12 than 70. So let's eliminate the b's this time. We want to get rid of those b's. We said we can make both of the b's have a coefficient of 12. So if I'm making it 12, this one needs to be multiplied by 3. 4 times 3 is going to give me that 12 that I want. Multiply everything times 3. Negative 28 times 3 gives me negative 84. The bottom one also needs to be 12, but this one's positive 12, so I want this one to be minus 12b. So we're thinking through 6 times what is going to give me that negative 12 that I want. I need to multiply times negative 2. Negative times negative is positive 14a. Positive 6b times negative 2 gives me negative 12b. That's what I wanted there. Negative 42 times negative 2. Negative times negative is positive 84. Adding my equations together, these cancel. That's what we wanted. 30 plus 14 is 44a equals negative 84 plus 84. That's 0. Dividing both sides by 44, 0 divided by any number is indeed 0. A equals 0. Plugging 0 in for my A, 10 times 0 plus 4b equals negative 28. 10 times 0 is 0 plus 4b. Divide both sides by 4. Gives us b equals negative 7. A equals 0, b equals negative 7 is our solution to example 3.